this kind of looks like an onion, basically because you can peel back the layers, and that's going to be an important thing to think about. So really quick, what happens? So let's say if I put a variable in here, if I put some like integer that's like an age, anything that inherits from animal, so anything that it's connected to, even indirectly, as long as at some point inherits from this, it will keep that integer age, even though you won't be able to see it exactly in this class. So just because, even when if you were to create a dog, you can assign it an age just because it inherited the age integer from animal when it was created, okay? That's really key to understand.
Okay, so age would be for all of them?
Yes.
Oh.
So even, I only had to type age once, and just by saying that they extend animal at some point, obviously this extends dog, which extends animal, it gets this age. Okay? Yes.
So then if you're saying age, but you only like talk about like age for as in like calendar year, but for dogs, so it might be like dog year. Would you put like a
yeah, we're gonna cover actually exactly that. It's coming actually. It's exactly what you're talking about. All right. So onion diagram, understandable. Age. So I'm gonna do one more thing. So I'm gonna give it this other class. I'm gonna say Earth. So we're going to say all things from on Earth, animals.
Okay. Is that subclass or does?
Yeah, we're going to make animals is now a subclass of Earth.
Okay.
So this is the other important thing to note. This is just for the sake of this example. Earth will not have an age. Okay? Animal will have an age, dog will have an age, husky will have an age, cats will have an age, fish will have an age. Earth does not have an age because it doesn't inherit that age. Anything that's created goes down. Remember the diagram, Earth, so the age appears right here. Earth exists now and up here, okay? And as a class, when you do this diagram, this is a helpful one because it's easy to look at and say, what variables can I access? Only things in. I can only go in. I can't go out. One way, because you only can peel an onion back. You can't put an onion back together. You only peel the outer layers, okay? Important concept. We're going to cover it a couple more times. Now, time for a little bit of a ghost story. So, you guys remember constructors? How to construct an object? So, I'm going to tailor my example to this because you probably don't want to hear about space biology. Basically, I was creating some animal, and we said, great, we'll give it a constructor. We'll make it a default constructor. And then we're going to inherit, like I'm going to create a dog, create some huskies. So then I'm like, great, I'm going to create a husky. I'm going to create a dog. And then we were running around and we said, wait, having this default constructor isn't so great. We kind of need to give it it's better to always give it, some kind of information, like its age or maybe a DNA, the DNA sequence, which is some other object. So we said, okay, we'll change it to another constructor. We'll give it an age. We'll give it some DNA. Okay, and then we said great. And then we were going around creating huskies, and it said error, cannot find constructor, and throw whenever you tried to run and create a husky, the program would crash. And we said, what the heck? Because we changed animal and husky broke. So this took us like an hour at 2 a.m. to figure out why. And I'm going to preface this with a little bit of what Java does for you that you don't see. Okay? So before you know why this breaks, I'm going to explain a good programming practice that you should listen to. And also, there was one question on the AP test that covered this, and I definitely got it wrong because I didn't know about it until then. So, here's what happens. So let's say I want to create a husky, okay? So I'm going to write this down here lower because it's just going to help me. So, in your husky, you may pass in some variables, things like that. Here's what happens. There's a line of code that you don't see that happens automatically. It does it for you, and it's just to help you out, okay? So when husky extends dog, and dog extends animal, the first thing it does, remember the onion, the first thing it does is create the highest level object, okay? So what it does, it says, great, we do what's called super. The single line of code that executes on its own, you don't see it happen. Okay? If you don't put it in there, it'll do it for you, basically. And if you specify, it won't do it for you, but you can specify. So if you don't specify, it runs this line of code, it says super. Super says, go to the super class and create that object. Okay? So it says great. You go, great, understandable. It goes up to dog. And then dog says, okay, first thing you gotta do, create the super class. So the important thing to remember is we haven't even done the second line of code here. We jumped from one constructor to the next constructor, and we still haven't got to line 2. Okay, maybe we give all huskies the age, we give huskies the age 10, for example. This line of code won't execute yet. Okay, it's still jumping up the list of constructors because it needs to create the highest level object first. So now on the final, we're going to erase Earth here for this for now. So the next thing it's going to do is it's going to call animal, and then it calls super on animal. And where does super go from here? There's nothing left. Even if there was Earth, it could still keep going past one more. So there's a thing in Java called an object class, okay? If you don't specify, it extends object, okay? By default. So actually this calls what's a class called object. You can look it up. Anything you ever create extends object at some point, okay? It'll extend some class later. This is the highest level class you get. So actually animal extends object if you don't specify. That's not super important to know yet, but it will come in handy in one chapter, I believe. So what happens is object does some stuff, you don't need to know about it for the AP test. Just know that it creates a couple of variables and some information that helps you out later, okay? So then it jumps down to animal. It finished calling super. Maybe you have some lines in here. Then it finishes that. Then it goes down to dog. It finished dog's super call. Then it goes down and finishes dog's constructor. Then it jumps finally back down to husky and assigns the age 10. Okay? Did that make sense? What just happened?
Can you repeat like the very last
The
one?
very last part. Okay, so when you call super, it stops execution right there. It'll jump to the super class and try to call its constructor. Okay? So it does that, then that, then that, then up here there's code here you don't need to know. I'm gonna leave it blank. Just imagine code happens, okay? Code happens here. It'll finish its execution. We were on this method in animal, so then we can execute more lines of code here. Once we finish animal, we can go back down to dog and finish the other lines of dog. And then finally we get back down to husky. We just finished husky's call to super, and then we can assign the age 10. Okay? Did that 2 times through? Are we?
Wait, so did super initiate like all of them?
Yeah. Super made a call to dog. Dog makes a call super to animal. Animal makes a super call to object. Object finally does stuff. It finishes, and then you can continue in animal. And then when animals finishes, you can continue in dog. And when dog finishes, you can continue in husky. Yeah.
Is that the constructor that you coded, or is it just automatic?
That's part of the ghost story. So remember the thing I said is if you don't say super, it provides this line of code for you. If you don't type this, it does it for you. It's mystic. You don't see it. But here's the important thing to remember. So super with no parentheses calls a default constructor. It looks like that. So what happened is we changed animal to this. So now there's one other thing Java does for you automatically. If you do not provide a constructor, it will provide a default constructor for you. A default constructor takes no parameters and constructs the object with all values initialized to like 0 or null. Okay? It does that for you. So if you have a constructor, it does not provide a constructor for you. Okay? It makes the assumption if when you're writing code, if you don't provide a constructor, that you don't know what that is. okay? And it says great. I'll give one for you. If you provide a constructor, it says you clearly know everything about Java and all the caveats of constructors. You don't need one, okay? So that's where this problem can come from. So here's what happens. Here's what caused our little ghost story. We changed animal to take in an age. This was not, we did not have a default constructor. This code doesn't exist, okay? So there's only one constructor that takes an age. So it calls Husky. When we create a Husky, it calls super. Dog calls super, and it says, wait a minute, there's no constructor that takes in no parameters, okay? Because before, we had no constructor given, and it provided us a default. We created one and lost the default that is called implicitly, that you can't see, okay? Is this clear, what happened? Kind of, somewhat of a ghost story. Are we getting it? Because we changed animal, we called Husky, and dog broke. Like, what the heck happened? So, does everyone get that then? The default constructor is not provided because we already created one. So, to avoid this, create a default constructor always, if you're looking for the quick fix. However, the important thing to remember is now how can we fix this code without creating a default constructor? So, you can try this. We'll try it in a moment. But so you can actually make a call to super, and you can give it an age. So I wanted maybe. At this point, it's kind of weird because I'm defining an age in Husky. Maybe I want all my dogs to start at age 1. I can make a call to super with 1, the integer value 1. And it will know to call the constructor in my super class with a singular integer parameter. Okay? You good on that? Makes sense? Okay. So that's fixing it with one way. The other way is to add this line of code here. A default constructor. Both work. So that's what happened in our ghost story. So, are we good on that specifically? I want to be very, very clear that understanding some of this is very, yes.
I'm sorry, are there a bunch of midterms in here? Oh, I'm sorry. Continue with your class.
So, but is this one, like, if there's anything that's not immediately clear on what just happened, how that works, this diagram, these two diagrams, how all this code executes, now is a great time to ask. It will get more complicated. Okay? Yes.
Can you repeat? I still don't get why it didn't.
Why it didn't work?
Yeah.
Okay, so this line of code doesn't exist unless you specify. Okay? Imagine this is invisible. Because when you create an object, you always just assign some variables. This is called automatically if you don't specify. It looks exactly like this. If you want your code to do the exact same thing, you can add one line of code. It'll appear to do nothing, but it just does exactly what the code does automatically. So at the moment, I had a default constructor for Husky and I had the default constructor for dog, and I did not have a default constructor for animal. When you provide a constructor of any kind, Java will not provide a default constructor for you. If you do not provide a constructor, Java will provide a default one for you, okay? So there are two things that Java does for you. If you do not make a call to super, it will do it for you. If you do not have a constructor, it will do it for you. Both of these are defaults. They will take no parameters, and they will assign all member variables to null. Not very helpful, okay? But it does it for you. The point is, if you don't have it, it'll try to make an assumption, okay? So it can, basically your other code won't work. So what happened was I changed I had the default constructor that was doing it automatically. I changed it to have an age. So then what happened was I created a Husky. I wasn't provided the default, so it called super to dog. Dog already had a default constructor, which is good. It tries to call super implicitly, which means I didn't type the code and it's making my assumption. It says when I tried to call super,
It's not there.
it's not there because I only have a constructor that takes an integer. Okay.
Okay.
So there's no matching constructor that can create an object to type animal, and in the dog class, when I changed animal and created a Husky, caused the problem.
Got it.
Okay. It's a really wild error. Okay. This is to understand exactly what's going on. I'm gonna make you an example for you guys as well. We're gonna create some classes. Yes.
So if I have this right, it's essentially trying to assign age that has to be called the dog, and then try try to call it the animal, but since that code was sort of null, it couldn't and sort of register as an error.
Yeah, so when I call super and it does it for me, it says I'll use the default constructor. Usually it'll provide it for me. However, I specified a constructor with only an integer, meaning Java doesn't create the default for me. The implicit call it makes by assumption is the default constructor, which now doesn't exist, and that's where the error comes from. Okay. This is, I know it's a little bit complicated. So now I'm gonna recreate this error for you guys, just so you can kind of see what how this works, and we're gonna have some fun filling with this. So you guys can ignore all of this. I just want this chain right here. We're gonna create a couple classes. Today's gonna be a little bit more fun in that sense. Okay. So is everyone's got Java running? Good to go. We're all ready. Do some people use IDE 1 still? Did we get over? Okay. You're going to create 3 classes, just like this, okay? I'm going to provide some code to help you out. But basically, we're going to create 3 objects. Name the classes animal, dog, and husky. Unless you hate dogs, you can name it cat and then some subset of cat, like fat cats, something. So, but this is the important thing. You want an animal class? Okay, so there's going to be three files you have to create on top of the main where you're running your code. Class animal, class dog that extends animal, and class husky that extends dog. These are 3 files. You're going to name them animal, dog, and husky, and you're going to add these lines of code. Okay?
That's just the instructions.
Okay. Are we good? Is there...
It's same thing like that one, right?
Yeah, we're gonna talk about this code specifically, and I'm gonna make some changes over here.
All right.
Today's gonna be a little bit of fiddling. I feel like it's really important for you to try this out, and I'm gonna have you try a couple things. Because I want you to get a feel for this. This is definitely not something you do normally. It's something you do like implicitly when you think about things, like you're like, all things that are alive have an age. Duh. But like to translate out of the code's a little weird. So I wanna make sure this comes out good. Yes.
Tell me like what software should I download?
I would highly recommend. Okay, do you have Java installed already?
I think I do. Yeah.
Okay, so like Java SE 10 or something like that. Did you download some Java 10 9? Did you? Okay. Yes, in just a second. Okay, does everyone have this so far? Are we all, wait, just to confirm, I'll come to you in a moment. Does everyone else have this? Three classes, these 3 names? We good to go on this? Mm-hmm. Okay, so you should have one other file open, somewhere you can run your code from before. Mine's called Test Center. It's just another file. You're gonna add a main. Add a main to the Test Center file. That's completely separate from all 3 of these. Go in there. Make sure these files are completely empty. They just have the class name and their extends. The only lines of code should be the name. Try to create a class and try to create an animal. Okay?
I'm so sorry. This might be really like dumb, but can you like go over the syntax for the 3 classes first? Like actually how you have to write it? Wait, no, I mean like.
This is one file. This is 2 file. This is 2 file. We're gonna go over there for a moment, but yes. What? No. This should be a whole different file altogether. You should have 4 files: animal, dog, husky, and then I want some other file to run your code. Okay? I have another file called test center where I write all my code to run. Okay? So you should have 4 files open. 3 for the animals, dog, and husky, and then I have one called test center that runs my code. Now I'm gonna really quick. Okay, you have Java. Okay, that's fine. Download what's called Intelligent Communication. Yeah. Oh, you're good. You're good. Yeah, you can put it right here. There's just going to be professional ultimate community. The community.
Test center.
Yeah. So again, the name of this file doesn't matter. I have mine called test center. That's what I called it. It'll just look like class test center, and then you have a main. Do public static void main. Sorry. I generally just write main when I mean public static void main, just because it's kind of a lot to write. If it's not clear, ask me and I'll specify.
So test center is its own class?
Yeah, I'm using it to run my code. It just needs to be separate from these 3, because there's a couple of weird errors that can be
Does
generated.
that mean it has to be on a different page?
Yeah, different file.
Oh.
Whole other file, just this.
Oh.
Yeah. File 1, file 2, file 3, file 4. Most people already had like something open already. Like some place you're running your code, it maybe have been called main.java, hello.java, untitled.java. Some class that you already were writing code in, that's an okay one to write this in as well. I just named mine test center because, long story, there was this typing game in like elementary school I used to play, and they called it test center, where you took the actual typing tests. So.
Is it the same thing using Dr. Java? I don't really get it.
Dr. Java? Yeah, new probably.
So I just create a new file basically?
Yeah.
Okay.
Yeah, you need a new file for
Copy and
each one.
paste this.
Yeah.
Alright.
So you can actually do multiple files in the same, or multiple classes in the same file. Not good for this though.
Okay.
But wait, each one gets their separate files.
Yes, there should be four files. This is a file, this is a file, this is a file, and then you have something that runs your code that I'm calling test center. You can name it whatever you want. The name of this doesn't matter. These 3 do, okay? Most people already had a file called like untitled or hello or something of the sort. That's okay to run your code, your main in as well. These just have to be 3 different files from that. Okay? Is there anything unclear still? I know this will take a minute, but I really, really, really want you to actually type this out for code, okay? Because you're gonna run into a couple weird things, and I'm gonna explain it. Okay. So are we good with this? We're feeling this makes sense?
Test center is one word, right?
Yes. Class names should always are all one word. Yes. Underscore is fine. Officially, Java uses camel case, which is all no spaces or underscores, and capitalized at the start of every word. I switch between the 2 because I also teach a Python class where they don't like camel case and you're supposed to do underscores. So I switch a lot. I'm sorry. As long as you stick to one and don't do exactly what I do, which is switch between them a lot, you're okay. Are we good with this now? Are we getting closer to that? Sorry. Now that's more clear. Is it downloaded? Close. Yeah. So open it up. New project.
Yeah.
And then you can name it whatever you want, like Hello World or like Fremont STEM APCS or something. I don't know. Not super important. When it's done, actually raise your hand. Okay, I want to come around and make sure that we're good to go. Okay. Perfect. Make sure the extends is next to the names. The braces come below. Okay. Yeah. Perfect. Yeah, we're gonna get to the H part in a moment here. Okay. So now you want to create files, you can right click on. Yeah, SRC. Okay, and you can create those three. And you can use this main.java. You don't need test center. Perfect. Okay. Okay, can I see the three files?
Oh, this one?
Good.
And this one? This one?
Perfect. Alright.
Okay. And then there's the dog one.
Oh, you only need one. You're just different files. You don't have to open a whole new project.
Oh, I just copied.
It's good? Same thing? Okay.
No, it's just. I thought there was a space.
Okay. Looks good. If you build your project, do all the red lines go away? No? Does no code run at all? Like, have you been running code that's been working? Or is it just like a weird bug? I'm just curious.
So like I can share all these.
Oh, you capitalized A. You have to name the file capital as well.
Yeah.
No, name the file itself capital.
Seriously, yeah. And you can print it out too if you want.
Use refactor, by the way, just to make this a little bit easier. Okay. All right. So in your main, you've got this, right? Perfect. Makes sense. Okay, we're going to add a little bit of printing. We're going to now talk a little bit about polymorphism as well. This is all an elaborate example to show off everything all at once. Okay, so we're going to I have object, animal, dog, husky. Don't have to ever write any code in this. Okay, so I'm going to erase it. Okay, so this is going to be in the animal class, that highest up animal class. I'm going to rewrite it right here. Okay? We're going to add that in age. Okay? You good with that so far? Okay, we're going to add a constructor. No parameters, no code in it. Just add it, okay?
Do we still need the colon, semicolon?
Colon,
I
semicolon?
mean, like, do we just need that thing?
What? Oh, like, wait. What colon, semicolon thing?
Sorry, do we need that? Yeah.
With this over here. None of this over here is not worth it. We don't need this yet. This is what we're going to get to. We're going to get to this arrow really quick.
Okay.
Sorry. I just don't want to do all these steps all at once. It's a little complicated.
Okay.
Okay, so we have our default destructor in animal, and we have the integer age. We're good on that so far. Okay, now just to show you that there's no compiler error and I'm not just crazy, we're going to jump into our class dog. We're going to give it another integer val. We're going to give it an integer called legs. And we're going to give it its own constructor as well, okay? Kind of off by a little bit. Okay, given a public constructor, we're going to pass in no parameters. The first thing we're going to do in the constructor, we're going to have one line of code for now. Assign age the value 5. So, no compiler error. Compiler doesn't complain. Remember? Oh, I should probably write this in here instead. So, no compiler error. Remember from here? Same diagram from before. It inherited age from animal. So it does, even though we didn't define it anywhere, it's been predefined already. It assumes that it already exists. Okay? Are we clear on that? Why it gets age? Okay. So, now we're going to jump one more time. We're going to jump all the way to our last class. We're going to go to Husky. Okay. We're going to give it a string. We're going to make it fur color. And we're going to give it another constructor, public constructor. Default constructor, no parameters. And your fur color equals, I'm going to say white and black. Okay. I'm going to pause right here for a moment. Ignore the fact that I'm missing bottoms braces. There's going to be code that's going to get added for us to again fiddle with this. We're going to learn a lot in 45 minutes. Okay, so now we're going to prove one more thing, and we're going to learn our first thing about what we can do with inheritance and a little bit of polymorphism. So from before, just coming right to what you said now. What if I disagree with something that was already done? Like, that's great. All my dogs have an age 5. My husky is 3. You know, like, what? How do I? That's not so good. So what I can do is I can specify otherwise. Okay? I can specify otherwise. We won't get a compiler error. This is just a very simple, it's called a variable overwrite. Okay? This is overwriting what was in a superclass, okay? And this you can do slightly, we're going to get to even, you can override almost anything, by the way. We're going to cover what's called a method override as well. And that's the part of polymorphism. That's where that comes from. All right. So, are we clear on this so far? We have a dog, it's age 5. We have a husky, it gets a fur color white and black. It gets that string coming in, and an age 3. We're good on this so far? Okay, really quick, we're going to jump back into our main right here. We've got this a new animal. You don't need it for now. I just want to prove to you that if you wrote this code, it would work. And just to make sure. Okay, ready? We're going to create a dog. I'm going to call it dog D. Whoops. Dog D equals a new dog. Are we good on that? Okay.
But do you keep the animal A equals new animal?
No, you don't do it.
Oh.
And then we're going to create a husky.
Did you delete the animal?
Yeah, you don't need it. I just wanted to prove to you that you could write that code and it would work.
Okay.
Two lines of code really quick. Run it. You're not going to get anything printed. It'll run and finish with exit code 0 if you've done everything right so far. This is just a double check to make sure we're all good before we continue. Okay? If you get some type of error running this exact code, please say something now. Okay? Because there's going to be a couple of times where I'm going to have you write some code, run it, and see what happens.
It should say run test center, right?
Yeah, you want to run the main in test center. Run this code right here. And it should run exit code 0 or something of the sort.
Sure.
Yes.
So like for Husky, I accidentally put age equals 3 outside of the
H
constructor.
equals 3.
Oh no, I put it outside of the constructor and there was like an error.
Yeah.
So why? I thought you defined.
You tried to redefine a new variable called age. Or sorry, you said age equals 3 outside your constructor. You can't
for Husky.
write code outside of a method that isn't assigning global variables. So if you tried to create another global variable called age and dog, it would throw an error because it already has one called age, inherited from Husky. So we're good?
Yeah.
Okay. So if we're good on this so far, everyone, thumbs up? Okay, ready? We're going to have a little bit more fun now. Okay, so we're going to jump back. I'm going to give you the ghost story, exactly what happened, and the sadness that I went through. You have a question?
Yeah.
What?
Something wrong with my main code.
Main code?
Yeah, like,
Does not recognize any keywords.
so the very top one, like, I don't know if we're trying to public site void, it's saying it's saying it's a illegal type, like, on void.
You have a compiler, or it's trying to find your compiler and it's probably missing. I'll get to you in a moment. Really quick, we're going to add this. We're going to add some code. I'm going to recreate our error from before. We're going to see what happens. Go to animal, really quick. Change our constructor. Take in a parameter, call it, and we're going to call it age. Okay? Now, assign that variable locally to the local variable for this object. So this dot age equals age. Okay. Now go back from the main and see what happens. You are missing the last name. I will fix that. Do you mind?
Oh, this is a run class.
If I want to do that, it doesn't work. Yeah, if I want to tell what when I removed it, it's hard to recognize me.
That's its own. It was in a different file. Okay, so you try to run the code, it doesn't work.
Okay.
And you go, what the heck? The error comes in probably right over here in dog. It says no argument. You know, it's looking for something. So here's our error. We changed dog. And this one we try to create a dog. If you create a husky, it'll do the same thing. You're gonna get that same error.
Wait, can you repeat what you said?
You changed animal, you added an integer. Now in dog it says there's a problem.
Yes.
It's kind of weird, right? You change one thing and the problem happens somewhere else.
Inheritance again.
Yeah, so this is our inheritance, this is the ghost story. You changed animal and dog broke, and you're like, what? How did that happen? Okay, so I'm gonna show you how to fix this. So remember that called the super? We're gonna add one line of code right here, called super. Don't add anything yet.
So we delete the age completely.
Yeah, for now. We're gonna probably add it back soon. Alright. Make it called super. Don't put anything in it yet. I want you to put it in and then check the error again. It's gonna give you that same error. So if you read the error message, it's gonna say that same thing, like no argument, no constructor found that passes in an age. There's your hidden line of code that runs on automatically. So I'm going to show you solution 1, which is you tell Java, I know what I'm doing. I don't need a default constructor. Pass in your value, your age 4. I believe it was 5 before. Our dog was 4 now, I guess. Pass in 4. Try to run the code again, and it will magically work again, okay? Yes.
I'm getting an error. I don't know.
Where or... Oh, you have 2 classes. Yeah. Actually, you don't want to. You have. You're gonna want to take that brace right below it. Remove that. And now you can. Okay. So do we run this code? Do we run this code and watch it run and exit and be done and there were no errors? Beautiful, right? Yes.
Is there an advantage to doing this and making that and changing all the animal constructor to int age instead of the default constructor?
Yes. So good programming practice is to provide a default for everything. Okay? So you don't run into this problem in the first place. You do have to know what the super does though, which is why I'm explaining this ghost story and teaching you how to use this as well. So provide the default's good. Providing extra constructors helps you to create objects when you may not have all the information. For example, like there are times where I only know the age of a dog and I just want to create a dog. You know what I mean? I just kind of gotta, well, yeah, I need that. So now, there's constructors. Obviously, I only have one parameter for age for animals. So maybe I'll have a dog constructor that takes in only the amount of legs it has because I don't know the age. I'll set the age equal to -1 because I don't know it or something. You know, some value that's invalid. I could have another constructor that takes in 2 integer values, both legs and its age. Then I can get all that information in one go. And then I could have a default constructor, which is usually what this is supposed to be, where it doesn't do, it all it does is assign variables to default values and leaves it for you to work with. So now that we got this, we have time? Okay, good. My computer's dying. Okay, so we're good on this now? We understand what happens, how that fixes it, right? Why adding an integer value makes this go from can't find constructor to good. We understand that? It was kind of that AP problem from before where we were looking for constructors with the same types in that order. You got that good? Okay. So we're going to have a little bit more fun. So we're going to keep the int age. We're going to keep the super 4. We're going to jump over here. We're going to have one line of code at the very start. I'm going to just write it really quick. Give it a super. Give it nothing. Okay? Just write super, put no parentheses, or just put empty parentheses, and then your semicolon. Run the code one more time. and it runs, exits, all fine and good, right? Adding that line of code did nothing. All we did was just specify something it does automatically, okay? Are we good on that? Makes sense? Yes.
That's static void error.
Static void error?
Like static error.
Are you running the test center?
Yeah.
Oh, no.
Oh. Yeah, you want to run the main, run our 2-line main in test center each time, okay? All right, so adding super did nothing. We're clear on what super does, right? We're good on that? All it does is call the constructor of its parent, okay? All right, okay, well, a little bit, now time for more fun. So we're going to change a little bit, we're going to backtrack a little bit, change a couple things, and I'm going to show off how it does it automatically, okay? So really quick, you can delete age from here. Delete age in the assignment, leave it as a default constructor. Once you're good with that, delete dog's constructor altogether. Okay? All 100% deleted. Run the code one more time. And let it see what happens. And what is the error?
No arguments.
No arguments? In dog?
In dog, yeah.
In your animal is nothing here? Just to confirm, I want to make sure.
That's no error.
You got no error? Yeah.
I didn't.
I forgot to do that.
Okay. So we have no constructor here, and our code runs all nice and fine. So remember, if you do not have a constructor, Java will provide one for you. What it did was, behind your back, it said, you know, I have to use this. You don't have one. I'm going to create one. It creates the straight blank one. It'll then call super. Again, that's an implied call in the constructor it creates for you that jumps to animal for you on its own. Okay?
During the AP test, do we assume that we have a constructor?
Yes, it'll usually provide one for you. But it's important to know if you don't have one, it'll do it for you. Okay, this is one. There are a couple questions that do this on you. They're like, there's no constructor. Haha. You know, and you have to know that, it's just default. Call super and we're done. All right, we're clear on that then? That it works? Okay, we're gonna really quickly add a couple more things. So I'm gonna add a method. I'm gonna show we did a numerical override of a variable from before. We're gonna do something a little bit better. We're gonna change a method. Okay? So we're gonna have our animal class. Let's say all animals can walk, okay? So we're going to add a method. Okay, just like this. We're going to call system.out.println. We're going to add this line. Is anyone unclear how I did the method? Public, void, walk. We specify the scope of it. We specify a return type. We give it a name. We put in parameters. We don't have any for this one. Single line of code. We're good on that? Okay. We're going to add this line of code really quick. Give it a public void walk. And we're going to add a couple more print line statements, okay? So, leaving your animal constructor as a default, we're going to add a print line. Okay, just really quick. I am an animal, and you're in your constructor, okay? We're going to recreate dog's constructor really quick. And then in Husky, we're just going to add this at the bottom for now. Same print, one more print line again, okay? Okay. So just to confirm the change we made, I added I have a method called walk. It just prints out I can walk. We have animal that our constructor prints out I'm an animal. We have dog that prints out I'm a dog, and we have husky that does some stuff and then prints out I'm a husky. Okay? Super quick. We're gonna go back over here and we're gonna run the code. Okay? Run our main. It's gonna print out 5 statements. And tell me the order.
Animal, dog, and husky.
Okay? You got it? You ran it? We all ran it? We're good now? So, in the console, you're going to get 5 lines of code, or 5 lines of text. It's going to say animal, dog, husky. Correct? We're all good on that? It came out like so. You all got that? Okay, so remember how we talked about how the types are created? We're going to run through it one more time. I'm just using the print commands to prove that I'm not crazy again, and I want you guys to figure this out. Okay, so remember, this print line that said came out I'm as husky, and what we created over here was a dog and a husky. So we're going to do the dog one first. I'm going to run through the husky as well, okay? So the first thing we started out is we said we wanted to create a dog. We jump over here. We have called a super that we can't see. Remember? It pops up. We don't know where it is. It says create the class above it. It's superclass. It jumps to animal. Comes over here. It prints out I'm an animal. It finishes the constructor, which finishes the call to super. It jumps back over here and then prints out I am a dog. And then it finishes its constructor and is done. And that's this line of code. So that's where the animal and dog come from. The next 3 lines of code are animal, dog, husky. So we're going to jump over here. We have specified a call to super. We wanted to do exactly this. So it jumps over to super. It says, I'm going to create dog. We have not specified super. It will do it for us. It jumps to animal. It prints out animal. It finishes its constructor. It jumps down to dog. Prints out I'm a dog. Finishes dog's constructor. Then does fur color equals white and black. Age equals 3. And finally again prints out I am a husky. Okay? Clear, right? How this is now working? Yes.
For the test center, I thought they're just initializing or making the 2 objects.
Yeah.
But how does it run? How does it make it print? I thought if you're not doing anything.
The print statements. That's what it's printing out.
Oh, I thought don't you need to use write D and then use it or.
Wait, what now?
I'm not too sure why it just prints it out immediately. Because I thought for objects, I feel don't we need to do something with D and then it will print it out?
No, because when we call the constructor to create the object, it prints it. Okay, I'm really quickly going to run over this notation to explain why it printed, because I think this might be a question that people have. We didn't actually print anything, and it printed stuff, and what happened.
Print twice.
One time we called dog, and the other time we called husky. So that's where you get animal dog, and then, so if you delete this,
Animal, dog,
if you delete,
dog, husky. Oh, because oh god.
yeah, so if you delete dog, just so to confirm I'm not crazy, and if you want to be 100% certain, delete dog, just run the single line husky, run it, you're going to get animal, dog, husky. Just straight, okay? Just to confirm, yes.
So if I had the class, the class for animal, and I called it Earth, and it said this is Earth, would it print this is Earth before animal every time?
Okay. This is a little weird, I know.
Tell her. No kidding. Sorry.
Okay, but we're good on this concept? We're feeling it? So I'm going to really quickly run over what happens right here on this line of code, okay? So for right now, we're going to delete the dog line of code. Okay, so here is what happens. This notation works as follows, okay? You specify a type. Remember, so this is the same way as you creating a variable from before. You specify the type. I want to create a husky. Okay, an object from the class husky. I give it a name. I'm going to assign it something, and I want to create a new husky. Okay, one that I haven't had in the code before. That's where the keyword new comes from. And then I specify the class name that I want. I want a Husky. And then I can give it parameters if I want to use its special constructor, which we don't have one yet. Okay? So that's where that's this line of code right here. New says go to the constructor. It says go find a constructor just like this. Okay? Just to be clear. This is like calling a method, but when you specify new and it's a class name, it'll go look for the class. Okay, so that's how it jumps to here, and that's how you get all the code executing in the way it did. Okay, just to confirm that. All right. Okay, so we didn't do a lot with walk yet. So I'm going to show you how to call a method on an object. So animal has this method walk. We did this as an AP question last time, and we tried to call this on an integer, and it didn't work because it wasn't of type rational number. Okay, we're going to do the same kind of thing. I'm gonna have you run a line of code right here below this on Husky. Call the function h.walk. Okay, h dot and walk and add a semicolon, unlike me. Okay, call h.walk. Run it again. You're gonna get 4 lines of code. Yes. You can delete the dog for now. Yes, that would just be. We don't need it for now. We'll need it for another little bit of time. Okay. Are we ready then? So we got 3 lines of code that says, I am an animal, I am a dog, I am a husky, and then I can walk. Okay, so we know where the other 3 lines of code come from, yet it's animal that has the method walk and husky that gets to use it. Okay, we understand? So, using our inheritance diagram from before, what I did was I added I'm just going to call it void walk for now. So I put walk in my class. Dog inherited walk from animal. Husky inherited that from dog. So that's how, even though again this is an animal, huskies can use it. Okay? We're getting this? Yeah. We're going to do a couple more of these. All right. So now we're going to do. Can you overriding? Let me think about this for just a moment. I want to make sure I get this out. All right. Okay, so we're gonna change our method from walk. In our new walk, we're gonna change it to flying.
I can fly and I'm a dog. Definitely works.
Yep. So we're gonna get into that, and we're gonna get it's called polymorphism, and it's called late or dynamic binding. Okay. So we're gonna change what comes in here to I can fly.
I disagree.
Straight Pete from Peter Pan. I can fly. I can fly. I don't have my Peter Pan cosplay, but all right. We got this. So we changed our code. It's great, except can dogs fly and can huskies fly?
Yes.
I mean, if you put wings on.
If we can put wings, is it the class called winged dog and winged husky? So we kind of have a problem here. We changed some stuff, and while it inherits it, which is nice, it's not really so good anymore because it doesn't make a lot of sense for dogs. It may make sense for a bird class that extends from animal, but we're kind of in a sticky situation here. So we're going to make a little adjustment. We're going to do what's called the part of polymorphism that's called dynamic binding or late binding. And we're going to change it. So, pay very close attention to what was exactly typed here, public void fly. We're going to go into our dog class, and we're going to add the same method. Okay, so what I'm about to do is called an override. Okay, a method override with some dynamic binding included. The dynamic binding stuff happens on its own. The important thing to know is what this is called is, you know how we changed age from 4 to 3 in one constructor? We're going to change a method. Okay, so I'm going to disagree and I'm going to say I can't fly.
But you can.
Maybe in my heart. Okay,
You can go to Walmart.
so here's the important thing. Okay, we're doing what's called a method override. The title, the declaration, what looks like the title of your method, where you specify public or private protected, the return type, the name of the method, and what's the parameters have to be exactly the same. Okay? Exactly the same. I put my code that says I can't fly now. Okay? Are we good on that? Let's run it one more time. Change this from walk to fly. Call h.fly. You're going to get 4 lines of code. Or 4 printed lines of text, I should say. And what do you get?
Can.
Can?
Can't.
Can't. It can't fly. We're good on that? We got it? I'm an animal. I'm a dog. I'm a husky. I can't fly. Right? We're good on that? You got this? Good? No?
I thought it was unrelated error.
Me too.
Unrelated error. You are calling walk. We changed it to fly.
Oh.
We changed it to fly. Make sure.
Change it to fly.
Oh, you changed it to fly? Oh, you have to wait. Oh, you need to put this outside of it. So the constructor is right here.
Oh, I have to
This
put
is a whole
outside
other.
of
This
it.
is another method.
Right. Okay, got it. Thank you.
Okay. All right. So while you get that, you can run it. I'm going to cover really quick. So here is what happened. Okay. So remember we call compile time and what we call runtime. Okay. So during compile time, we said this prints out fly. This looks like a method override. We're going to note that down, but that's okay. And then this looks fine. Okay. Now during runtime, we're doing something a little different. Okay. So at runtime, we're calling fly. Okay. Fly will go to the first available class. Okay. So what happens was the way it looks for a method is it looks for it and then it jumps up the ladder looking for the very first time it's implemented. Okay? That's how it handles a method override. So I called h.fly. It's of type Husky. It looks in Husky for fly. There's no fly in Husky, so it backs up into dog and finds an implementation for fly and uses it. Okay? Is that clear? It did not, so it doesn't ever see this I can fly because it ran into I can't fly first when jumping up from subclass to superclass. It starts at the innermost part of the onion, which disappeared, and moves outward till it finds what it's looking for. Yes.
It goes to that and comes back and just prints out.
Yeah. This is during runtime. It'll go look for it and find it. Okay? Usually it's already available and it just goes boom, done. It had to actually go find it.
But if you have like a separate subclass for animal called bird, you just wouldn't put that and it will still.
Yeah, we're actually getting to that. All right. So I'm really quickly gonna. We may not do the bird one actually. No, we won't do the bird one. Okay, really quickly, we're gonna add 2 more lines of code to our main. Create an animal, an actual animal itself. Animal A equals new animal. Then try to call a.fly on it. Okay, I know this is getting kind of low. I'm sorry.
No.
There's just a lot of stuff on the board that needs to fix this. Okay, now you should get another 2 lines of code plus the 4 you already had right below it. If it helps you visualize, you can delete the first 2, but I'm going to keep them for now. So you're going to get a printout below those lines of code you already had from Husky that says, I am an animal and I can fly.
Yes, you can.
Okay? So to confirm that this is an overridden method for dog and for its subclasses, this runs still even. It doesn't just disappear entirely once it's overridden somewhere else. That override is only true for its class and any subclasses. Okay? You can remember the kind of onion thing. When it goes looking, it looks outward until it finds what it's looking for. The very first implementation of a public void fly with no parameters. Okay? Are we good on this concept kind of now? We're getting a little bit better feel for it? All right. Are we ready for something that's a little bit weird now? We're gonna change a little bit of these up here. Yeah, we have some more time. Okay. So there's a thing called downcasting. You will never hear anyone say that other than me right now when I call it downcasting. So what happens if I do this? Remember, I said before, specify the name of the type, give it a name, say I want a new constructor, and then pass in the same type from before. But I didn't do that. I gave it a subclass. Run this code. Single line of code, run this code. What happens?
Basically, printed out the same thing as it would for Husky.
Yep. All right. What happened? But I said it was an animal.
No, but you're making it equal to a new value, right? So
That's
it
me.
changes its value.
Okay, now, ready for one line of code addition.
Yes.
Call fly on it.
Oh no.
What happens?
It's husky.
Print it out. What does it say?
I can't fly.
I can't fly. I said it was an animal. What the heck?
No, isn't it the same reason why? Because it's a new value. You assigned it to a husky, so
Yeah. So,
it's changed.
but I said it was an animal when I specified the type. So what happened? Why can't it not fly? I said animals can fly, and I made this an animal, but
It's a husky.
it's a husky. Okay, so are we ready for this now? So I said this was an animal. I created a new husky, and it said that's fine. Why? Why was this an okay line of code? Because an animal can't fly, and I created a husky, and it has an override. You know, it's different. Husky's a whole different type of thing. There is a singular. Will help you greatly on the AP test. This is a sentence. If you have anything worth studying about polymorphism, things like that. Here's a one line. This took me and my professor many years him to figure this out. Okay, ready? Where a superclass is expected, a subclass is accepted. This is the most important polymorphism concept. Okay, this non-inheritance polymorphism. Okay? This sentence may not immediately make sense. I'm going to explain it in the context of this really quick. Okay?
That should be my senior quote.
If you're feeling that, yes. Compliments of Dr. Phil Heller from San Jose State. All right. So I'm going to explain this. Do you have a question? No? Okay. Where a superclass is expected, a subclass is accepted. Over here, I said animal A equals, usually before I said new animal. What it expects over here is the superclass animal, okay? It expects the class animal. Remember from our diagram right here, conveniently wrapping around it, husky is a subclass of animal. So over here, a superclass was expected. I gave it husky a subclass, and Java said, no problem. A superclass was expected. I provided a subclass. It accepted it. Okay? Are we good on that concept? A little bit. This is a little weird, I know. Because you called fly on an animal and it said it can. You're just like, what? All right, we're gonna do one more line of code. Or I'll just write it below. One more line of code. Now I'm gonna say husky H equals new animal. What happens?
That line of code's an error.
And what does it say for an error?
Saying incompatible types.
Incompatible type. Okay.
Oh, it's because it's the opposite. Inheritance only goes downward, right? Not like.
Yep. Here's what happened. We said husky H is new husky. Let's read our quote one more time. Where a superclass is expected, a subclass is accepted. So we say husky H equals new animal. We give it a class, we give it a superclass of what we started with. Okay? And that's not a subclass of husky. It's a superclass husky. We get an error, incompatible type, cannot resolve, not cannot resolve. It'll give you incompatible type. It won't let you run this code. It's a compile time error. Okay? We're going to really quickly cover why that happens and what this equal sign and animal A equals new husky is doing. Okay? I'm going to erase this code. Do not delete it. You will need it. Okay? This is going to be an extended example that will proceed at least a little bit longer. It'll also be part of your homework. All right, so what happened?
Wait, sorry, before you move on, who was the professor again? I don't want to, if I actually end up using it, I don't want to copyright.
I can.
I might actually write this on senior quote.
Dr. Philip Heller.
My
PhD, SJSU Bioinformatics, 2016, graduated from UC Santa Cruz, I believe, with a degree in computer science. And
I'll just keep it at Philip.
Yeah, but Dr. Phil Heller. He is a beautiful man. I love him.
I love him too.
So, really quick, we're going to talk about what happened. Why a.fly gave me. Why did a.fly give me a call to fly when I pass in a husky? Now, what the heck happened? So, we're going to use our onion diagram to better understand what this is. So, remember, I said animal A. Okay? Animal A equals new animal, and I want to give it a husky. I have a husky. Okay? So, here's what's going to be A. with its nice big bubble. And then here's my husky. Okay, I'm gonna give it, I'll just call this new husky for now. Okay? Here's my new husky. Remember, it has animal, it has the dog, and it has husky. Okay? Sorry, wait. I should draw that yet. Okay. So, now we're going to talk really quick about equals, super fast. The equals operator assigns the thing on the left to the thing on the right. Here's my new husky I just created. I created my onion. Here's the space I have to put it in. Okay? So, does it fit? Does this fit? Can I fit one onion in another? This is an actual size question. Does the one fit in the other? We're talking about the top line of code. Animal A equals new husky. Obviously the code ran. So here's why that works. I may not have a dog. I may not have husky. But their most outer class is animal at some point. Okay? So the information copied goes great. Add the inside. Copy one from over. Copy it over. It works. I have room. Okay? This is a downcast. Okay? Because I'm going, the casting from here to here goes down the tree. Okay? That's where this phrase comes from. Downcasting is a weird word. This helps you more in a more general sense when writing code. Okay, let's talk about the other one. Husky H equals new animal. Okay? Here's my husky. Okay? Here's the type I want. So, it's important to remember, this is going to look weird. My husky is this though. Yes, it has these other parts, but my husky itself is this. Okay? I say husky H equals new animal. Basic, size question. Does that fit in this? No. Okay? So, that's where this comes from, why this works. This is one of the most test questions are going to be asked on this subject. Exactly what we did today, just for the record. Inheritance, polymorphism. These two. Okay? That and print reading for loops, and while loops, which we can do a couple of questions on.
Wait, can you explain? The new husky is just the whole thing, but
This one over here?
it's just a small.
Because I specified the type over here. I'm talking about husky specifically.
Oh.
It does, yes, husky does have an existing other part, but not when I specify. But I'm specifying the type right now.
Oh.
Okay. So here's the way to think about it. Okay. The reason this works is because there's information inside of it that can fit in there. There's room in my onion, right? To add the smaller parts in there, I can fit it in there. So, but here, I'm talking about husky specifically, and I want to add some information from animal. But I don't, remember, husky can't see outward. Remember how, remember how we can't go out of the onion? Husky doesn't know, it knows it's a dog, but it doesn't know anything about it. Because there are animals that aren't dogs or anything, there are fish that exist over here. It doesn't know about animal. It just knows that its superclass is dog when it needs to find other information. That's the only piece of information it knows. When you said extends and dog, that's all it knows. But it can only see this information. Okay? So I said I want to create an animal. It's got a method fly that it doesn't even know about. So that's why it says, well, I don't really know where to put this. There's a lot of, you know what I mean? Like if I tried to put animal here, it would look like this. And I only have room to fit there. Okay? Okay, so was this kind of copying thing unclear, what just happened?
Sorry, can you explain that?
Yes. So I'm gonna cover, because it did print out, what was weird is it printed out I can fly. Yet we copied over dog, right? Right? So what happened was here, there's room on the inside to add more information. Okay?
This one it doesn't.
On this one we don't. I expected the superclass, I gave it a subclass. It said that's fine, I can fit that there. If I give it a superclass when I pass it in, if it's expecting something smaller, it has to be that or smaller. I gave it something bigger. That's the problem. That's where the error comes from. Now to cover one more thing. I said a dot fly, and it said I can't fly. Or sorry, I can fly. My bad. It says I can fly. When I pass in a husky, it doesn't keep any of the methods from here, okay? It won't keep anything from husky. All it did was say, could this fit in that? Even though it can fit, but it doesn't save any of this information. Okay? It just said it can fit. So even though husky had an overriding fly, it did not keep it, as it does not add extra information from here. For example, if this husky had an age 3 and the animal would get the age 3 because animal is a defined integer value that it already has. The fact that a husky has a string value, it doesn't know about. Remember, we're talking about an animal. There are fish that don't have a string for their fur color. Therefore, it does not copy that information over because it cannot be sure that that information is present. There's a variable to hold it, okay? So the way it copies information is anything that is already existing. So in our example here, there's an age. I believe it was 4 from before. It'll copy the 4 over. The fact that from here the fur color is black and white, we don't know what animal we're talking about yet. You know, like I said, there are fish that don't have fur. So that fur color is a very specific thing that doesn't exist already. Only that age exists. So it doesn't copy that over. Okay? The other way to think about this is having more information is always good. There's information that we can't guarantee will be true. And we don't do that. It works both ways. Okay? Husky doesn't know about animal. It just knows that it is a dog, and that it can actually figure out that it is that, but it doesn't know that directly. So information in animal can't get copied over. From here, we know that we're in the right location, and information that's unnecessary we don't use. Okay? And with that, I will say your homework basically isn't anything super official. We're going to have a little bit of experimenting. Again, there's going to be a whole nother hour of this on Friday to maybe beat the dead horse, but just to kind of understand what's going on. Go home, try to experiment with our 3-class thing. Try to create subclasses. Remember this quote? Try to create husky A equals new dog. Dog something equals new husky. Try using the assignment. Okay? We're going to talk about that. Yeah.
Ethan, your dad's here. He's waiting outside.
I'm sorry.
You're fine.
We have to get to the most important part of this whole course. We having fun yet, guys? Is code cool? You can say no and I hate you.
Did I miss anything? I was out the last 3 weeks.
You definitely missed a lot. So, we learned to program in Java. The best thing you can do is to come to my office hours. They are Tuesday from 1 to 5 p.m.
Did you start working?
That's the best time to catch up. Have you ever written code before? Have you ever written code before,
Oh
though?
wait.
Yeah.
What did you, what language?
I did a little bit of Java, but mainly it's Python. I don't really remember anything.
Why say Wednesday?
Are we meeting over the weekend?
Okay,
I didn't know.
that's fine.
You say that?
I think we're meeting over the weekend.
Let me check my.
So what you missed,
No, it's just us.
No, I was meeting over the weekend.
Yeah.
what you missed was we covered classes, objects, which we just kind of used a little bit right now, and then how to create methods, some operators, for loops, and while
Now my
loops.
phone says 8.
You may have used for loops in Python and while loops. For I in range number, for I in.
I mean, like, I don't remember.
Don't remember. Okay. So we covered for loops, while loops, the kind of basic variable assignment, and then methods, which you just kind of saw a little bit of, that public void fly. Constructors, classes, objects, which is what we did a lot of dealing with today, and then we're into inheritance and polymorphism, which is where we are right now.
I think I understand like the objects. I get classes.
Yeah, you definitely would want to refresh on methods and then for loop and then loops because we're gonna use them. And then
I think I know what a while loop is. Like
Okay.
it's like while a certain condition is happening.
Yeah. Yeah, that's-
Others,
yep. Yeah, we'll cover that. Okay, then you seem pretty good in terms of like you can come to class on Friday and not be confused. Again, you can always ask me questions. Feel free to stop people if things aren't clear. Yeah.